So in EIGRP, summarization is very important feature because it's a distance vector protocol. It advertises the complete routing table. So when you do summarization, the advertisement that goes out will be less. Not only that, the receiving router will not the receiving router need not to process too many route updates. Summarization is really good. Summarization is good. That is one part. There is also another concept called stub, which is more important when it comes to hub and spoke design. So summarization with stub is very important for EIGRP. That will make this protocol more effective, more efficient. We'll be focusing on the stub later, but before that we need to have a quick revision on what we learned on summarization. Summarization also reduces the updates like stub, but stub is easier to configure than summarization. In summarization, you may need to try to match with the prefix length by putting the right subnet mask. And there are two different types of summarization. One is the global EIGRP, the auto summarization. You may disable or enable it. In the newer version of EIGRP, it is disabled. In the older version, it is summarization is enabled. We also have a manual summarization on the interface. Manual summarization is interface level summarization that will not be applicable for all the neighbors. The summarized route will be sent only to those neighbors connected via that interface where the summarization is done. Whenever you do summarization, whether it is global summarization or interface summarization, there is going to be a summary route generated dynamically in the routing table pointing towards a null interface. Because without a route information, route cannot be advertised. For a route to be advertised, whether it is a summary route or a detailed route, for a route to be advertised, the route need to be seen in the routing table. So if you want a summary route, that summary route should be there in the routing table. EIGRP takes care of that summary route. Summary route will be pointing towards null interface. So these are the things that we saw earlier in the summarization class. The first command on the top is what for the global EIGRP summarization. The below one is the syntax for interface level summarization or manual summarization at any point. Whenever you do summarization, you have an option to set the administrative distance, but if you don't set, the default is going to be 5. It's an optional one. If you want to set some other number, you may set administrative distance. 5 is default. So this is an example, the global summarization command and the interface level summarization command. And then the next topic that we need to focus is unequal cost and equal cost load balancing. See, in order to load balance, we need to have multiple paths to a destination. Only then I can load balance across multiple paths. For multiple paths to be seen in a routing table, those paths need to have same metric. We call it as equal cost paths. So whenever we have equal cost path, meaning same metric, same composite value, combination of bandwidth and delay. When we have same composite metric for a destination via two different paths or more than one path, same composite metric, only then the load balancing will be taken care by default. You no need to do any configuration. Load balance will happen if the feasible distance is same for more than one path. Up to 32 paths can be used for load sharing, but by default it is 4. There is a value called variance, which is set to 1 in order to disable unequal cost load balancing. Unequal cost load balancing is variance is set to 1 in order to support equal cost load balancing. We can go and tune variance in order to do unequal cost load balancing. We can go and change the variance from 1 to 2 or 3 in order to have unequal cost load balancing. But by default it is set to 1, which supports only equal cost load balancing. What is unequal cost load balancing? Sharing the load across multiple paths whose metrics are not same, whose composite metric is not same. By tuning variance, you can do that. This is the command by which we can set the variance value, the multiplier value. This allows the router to include the routes with metrics smaller than the multiplier value times the minimum metric route to the destination. Example, we see 3 paths between E and Z. Three paths, one via B to reach Z from E, one via C, another via D. The total metric is 30 via B, 20 plus 10. How? The advertised distance is 10. 10 plus 20 is 30. Here the advertised distance is 10. 10 plus 10 is 20. Here the advertised distance is 25. 25 plus 20 is 45. So we got 3 paths but not equal cost path. All 3 are not same. And we can see path via C is the lowest metric path. So that will be elected as a successor. This 20 is what by default multiplied by 1. 1 is a variance. So 20. The answer is 20. Any route whose metric is 20 or less than 20 should be considered. And this is the only route. But if I will change this variance to 2, I get 40. What does this mean? Any route whose metric is less than or equal to 40 should be considered for load balancing. So now this can also be included. This cannot be included. 2 reasons. 1, this route won't be seen in the topology table. That's why it cannot be used. Second reason, the variance is 2. We multiplied by 2. We did not multiply by 3. If I would have multiplied by 3, I would have got answer as 60. 20 into 3. 20 is the lowest metric, the primary root metric, multiplied by 3. So any root whose metric is less than or 60 should be used. Even now, root via D will not be considered because it did not satisfy the basic constraint called feasibility condition. The advertised distance is not less than the successor value. 20 is the successor value, no? The metric of primary root is what? Successor value. Because 25 is not less than 20, this is not going to be seen in the topology table. So whatever the variance you may change, it's of no use. It won't be considered. Which is what explained here. The next topic in EIGRP is WAN consideration. By default, EIGRP will consume 50% of the bandwidth for EIGRP's own communication. The bandwidth, let's assume the bandwidth here is 1.5 meg. Or let me put it in kilobits. 1500 kilobits. And it is going to take 750 KB, kilobits, which is going to take EIGRP takes. See, this is the link's bandwidth. But what if the ISP has granted us only 56 kbps? The link is capable of carrying this much, but the subscribed bandwidth is only 56K. EIGRP says I want this much, but you got only this much. Many times more EIGRP is going to demand, which is not available for us to give. Even though the link can provide you 1500 kilobits, we got only 56 kilobits. Just 56 kilobits subscribed bandwidth. So now traffic can go through this link when you run EIGRP. If you change some other protocol, you are safe. If you change the static route, you are safe. If you run EIGRP, not even EIGRP, no traffic. Because EIGRP needs 50% of the bandwidth. So we need to go and configure on the interface. Even though I have bandwidth of 1500 kilobits, I need to go and tell, no, my bandwidth is actually only 56K. When you say that, half of it will be taken by EIGRP. Half of this will be taken by EIGRP, not 750. Somewhere around 25, 26, 27 it will take. So we need to be very well aware of these things, like 50% of bandwidth it will consume, and then if you have a multi-point, we have a special consideration. What is that? You see, this is multiple point 1, 2, 3, 4. If you say the bandwidth here is 200 kbps, 200 kb, 200 kb, 200 kb. Now this is a multi-point link. Multi-point. You need this one single physical interface is a hub router talking to multiple points. It's not point to point like this. So you will be having some sub interfaces. Even if you don't have sub interface, you might have defined it as multi-point. So the bandwidth that you are going to tell to this port should be sum of these bandwidths. So I have to say 800K. When I say 800K, only then with each EIGRP neighbor you can have 200K, out of which 100 will be taken for EIGRP. So the bandwidth that you configure on the hub router should be sum of the bandwidths available on multiple points. The spokes point. So this is what we call it as WAN consideration. If you see, okay, there is another story to understand. Bandwidth utilization over point-to-point sub-interface using frame relay. By default, the serial interfaces are considered as T1, means 1.5 meg. But our committed information rate on the permanent virtual circuit, PVC, see, these are all the terminologies that we have in frame relay. In frame relay, the bandwidth is called as committed information rate, the subscribed bandwidth. PVC is nothing but the frame relay circuit, permanent virtual circuit. So we might have got only 256K as a committed information rate. But what EIGRP will think is you got 1500K T1 connection, 1.5 meg. Again, in which half it's going to block, EIGRP is going to block, but you really don't have that much. You just got only 256. So there you need to go and configure on the point-to-point interface saying I got only 256K. Bandwidth utilization over multi-point frame relay ATM. EIGRP uses bandwidth on the physical interface divided by the number of neighbors, which I just now did know in the previous slide. We had 4 spokes. So bandwidth on the hub should be 4 times of each bandwidth on the spokes. Or bandwidth on each spokes will be the hub's bandwidth divided by the number of neighbors. EIGRP uses the bandwidth on the physical interface divided by the number of neighbors on the interface to calculate the bandwidth attribute per neighbor. So if you see this, before going to example, let's read this one also. Each PVC may have different committed information rate. Then you need to consider it as point-to-point. If the PVCs have got same committed information rate, then you will sum up. For example, you see, the committed information rate here is same for all the spokes. Oh, sorry, here it is different. Here it is same. So for these same, you consider together as one multi-point and give sum of this. For the other one, you make it as point-to-point and you give exactly what the difference is. So here this is going to have 2 sub-interface, one for point-to-point, which is going to have the bandwidth, that is sum of bandwidth on each spokes. So that's what I explained here. Each PVC can have different circuit, different bandwidth in the circuit, different committed information rate. So we need to we need to set bandwidth in such a way that it won't be a problem. Multi-point interface, convert these to point. For this is the solution. Convert it into point-to-point, configure manually different bandwidths as per the committed information right on the PVC, which is shown in this. Now, this is equal CIR, same CIR on all. So you no need to worry. You can simply say for each sub interface 25 as a bandwidth for EIGRP to use, or you may use like this. You can have one sub interface for all the spokes that has got same bandwidth, so they will all be in same subnet. There will be another subnet given on serial 0/2, which is defined point to point because the bandwidth is different. That's about WAN consideration. Only if you are using EIGRP on the. This chapter is about EIGRP authentication. EIGRP supports MD5 authentication. Authentication is good. Before we accept a neighbor, we authenticate the neighbor. Why? The routers will give root. The neighbor will give you root. If you are receiving route from wrong neighbor, then all our traffic will be misguided. All our traffic may be misused. So we need to get routes from the right person. I remember one incident. Somewhere around 7 o'clock, it was raining. I was going out of a metro station in Shanghai. That's the first time in that part of Shanghai, because my hotel was booked in that area of Shanghai. So I came out and it was raining, and I have a big luggage. I was moving around. I couldn't see the One World hotel called One World. One World. I couldn't see anywhere. But before starting from India, I checked the map. It was showing right next to the metro. But no, I couldn't see. And in those days, I did not have internet in my phone. Means international roaming was very costly on those days. Even roaming between state was costly in India on those days. And now all over India, you got one cell phone fee. But in those days, it was very costly. One person, he was with one kid and with an umbrella. I approached him. I said, "This hotel, do you have any idea?" He said, "No, sorry sir, I don't know, but I can search it for you." He took his cell phone and he googled, and he said, "Sir, it is right in this place," but even I couldn't see. "It is right in this place. It should be somewhere here. It is here only where you are standing, where we are standing." And then he was trying to find it for me. And we just crossed the big metro building. It was very tall. And when we took right, there was no any big board outside, but there was a big glass door. In the glass door, there's a sticker saying One World Hotel. And when you open the door, the big world was inside. International level, big hotel with big pilots and big people staying inside. So that man was so nice. He did not misguide me to different place in the rainy time. He took me in the right direction. So knowing from whom the information is more important than knowing the information. From whom I am receiving this info is more important than just knowing some information. EIGRP authenticates a neighbor. Once the authentication is successful, only then the neighborship is established. The adjacency is going to be formed. First the neighborship and then the adjacency. First for the neighborship, the hello packets, they carry the message digest of the key ID and the key string. When a router receives a hash value of key ID and key string, it checks with the local hash. When the received hash and the local hash matches, then the packet is accepted as genuine hello. If not, rejected. So hello packets every 5 seconds they come with the hash value. So it's a pre-shared key, you see. On every router you will be putting the same key ID and the key string. So when I generate the local hash, it should match with the hash generated and sent by the neighbor, because we both use the same key and key ID. They cannot be different. So only those who know the key ID and the key string will be able to generate that hash value. Why the hash is sent? If a password is sent, someone will sniff and know the password and they will use it. So it is good that hash value is sent. Hash value. EIGRP uses only MD5 authentication method. It sends the hash value, not the simple plain password. Whereas RIP version 2, OSPF and ISIS supports plain text as well as MD5. EIGRP and BGP supports only MD5, whereas RIP and OSPF supports both MD5 and the plain text password or simple password. ISIS supports only plain password. Simple password authentications are like something is better than nothing. MD5 is the best. If you want to have just an authentication, something instead of nothing, then you may go for simple password authentication. But if you want to have real authentication, real security, we should go for MD5 or SHA, which is better than, more stronger than MD5. So MD5 authentication is what EIGRP uses, more secured. EIGRP don't support that simple password. Right. So EIGRP MD5 authentication, router generates a message digest, which is nothing but the hash value of the key and the key ID. EIGRP allows the key to be managed using a keychain. See, for EIGRP and RIP, we need keychain. For EIGRP and RIP, we need keychain. Using keychain, we define the key ID and the password, which is called as key string, which is called as key key string, all the same. EIGRP allows keys to manage using keychain. See, understand? EIGRP allows keys. So, not one password, you may have multiple passwords. You may have multiple passwords. EIGRP allows keys to manage. That's why you need keychain. Even if you have one key, we need keychain only. Otherwise, we lose the key. So, in EIGRP, whether you have keys or single key, you must go through keychain process. You need to create keychain. Even in RIP, it's the same way. We create a keychain. And then we will call the keychain under the interface. The number, the key ID number also matters. If two neighbors trying to form adjacency, they may have same password, but if the key ID is different, they will not form neighbor because the hash will not match. So specify the key ID, the key. Lifetime is an optional one. Lifetime, you can say this password I am giving is only for January, and that password is for February, and the third password is for March. You can have different password and different lifetime for that password, so that when April comes, automatically fourth password will get activated and third password will get deactivated. Why we do that? It is safe to keep changing the keys, because if someone somehow learnt our password, they cannot continue using for lifetime. They may enjoy the privilege this month because they have stolen our password, but next month they cannot. They will be kicked off. So using multiple keys with lifetime is good. So you don't need to rekey every time. Automatically that new key will get activated. You just configure today and leave it for next 5 years. For next 5 years, every month new password you have configured, it will automatically get activated and the old one will get deactivated automatically. That is why you need lifetime for the key. You need to set the lifetime. If you don't set lifetime, the key will be immediately activated and it will not expire. It will not expire. It is for lifetime. Infinite time. The validity will be infinite. Now the key ID also matters. If you have key ID number 30, key ID number 20 configured, first you configure 30 and next you configure 20. It will only first process the small one and then only the 30. Key ID 20 will be processed first, later it will process key ID 30. The order of key also matters. So this is the command to enable MD5 authentication for EIGRP. It's per interface. And this is the command through which you call the keychain under the interface. We have not configured the keychain so far. Assuming that keychain is already configured, we are enabling or we are binding the keychain to the interface. Under the interface, you call the keychain. You may have more than one keychain. We call it. We may have multiple keychains for different neighbor. Keychain 1 for neighbor router 1. Keychain 2 for neighbor router 2. You can have many keychains. Inside each keychain you may have many key IDs. and key strings password. So this is just to call the keychain. This is to enable MD5 authentication on that interface. But creating keychain is like this. On the global mode, we say keychain name, key ID 1, 2, 3, something like that. Or you can use your own convenient number that you like to have. If it is between router 1 and 2, I'll say 12. If it is between 2 and 4, I'll say 24. That is also okay. Now, this is the command to set the password, key string, and the password. And this is what I was talking to you, optional one. You can say how long this password, let's say the password is CCIE 1, 2, 3, 4, 5. How long this password you want to accept from a neighbor. Start time and the end time, duration, end time. You can also say infinite. By default it is immediate, start time is immediate. If you don't mention accept or receive. Accept or send. Send lifetime. Like this. Fine. So we got keychain configuration. Next is you need to go and apply it like this. You see this example. There's a keychain called R1 chain which has got two keys. First key is password is first key. Second key, that's the password actually. And the accept lifetime is January 1st, 2006, 4 o'clock, forever. It is ready to accept. But it is ready to send only till 4:1, just for 1 minute. This will be sent as a password, first key. Whereas the second key is forever, for infinite. And then we call this keychain, what is the keychain name? R1 chain. We call the keychain under the interface. And we enable MD5 authentication under the interface. That's all. You no need to configure anything related to authentication under router EIGRP, not necessary. Right? Similarly, likewise, we need to do in our R2 and we need to verify. So verification command.
Sir, one question. Can you go back to previous slide? Yeah. So in this one, the key one is sent for 1 minute, right? But it is accepted infinite. So when it send, when 402 happens, right? So it will start sending the key 2.
No, key 1 will be sent at the same time when key 2 and key 1 will be sent at 4 o'clock. Both the keys will be sent.
After 401,
after
will stop sending key 1.
Yeah, after 40, it will be keep on sending key 2.
Yes.
And not only that, it will be ready to receive key 1 also, but it is of no use.
But accept lifetime means it's still accepting.
Yeah, it is ready to accept, but who will send? If the neighbor is also configured to send, he will accept, but here the send is different. This is not the right example. Here they are showing here just, like that.
Okay.
This is not practically good to do. When you are not ready to send, this password, if the others are sending and you are accepting, what is the use? The other one is not going to accept you. You are accepting him and he is not going to accept you. It's of no use. Neighborship is Only two side. It's not one side. So automatically it will fall to this one. It will fall to this one. Because the sender is not going to send on the other side what is configured, you see, key 1. If both are sent infinite time, that is true, but only key 2, second key will be accepted by R1 and sent, whatever R1 sends will be accepted by R2. Only key 2 has got both side acceptability. Key 1 is not. So authentication won't come in the key 1 scenario. Key 1 is not a right example. This configuration is not correct. That's a wrong configuration. They're just showing you that you may have mixture of infinite and time frame. Verification, you type show IP EIGRP neighbor. Once the authentication is good, the neighbor should come up and check the routing table. You should see the route, the ping should happen. Now, if you want to troubleshoot, these are the commands. Debug EIGRP packets, and you will see EIGRP receives an MD5 authentication. The key ID is 1. Received a hello. On router 2, the key ID is different. So it should match actually. So what happens is, here they are trying to do some change to the password. Key ID 2, they are setting a different password so that you will see the debug authentication mismatch. This is a page to understand the debug command. Debug EIGRP packet.
Thank you, sir.
All right. Let me quickly show this. It won't take much time. Let's do a small lab really fast and then.
Sir, after this you will be covering named EIGRP?
Yeah, that will be last. After this we will need to do unequal cost load balancing. After that we need to do stub. After stub only we will do the newer version of EIGRP. Right, this is going to be autonomous system 200. Console. Alright, so I'm going to quickly configure using a notepad. These interface names are G00. The networks are 1 and node or somebody. This goes on router 1. Now on router 2, this is 2. This is going to be 2. This will go on router 2. Now immediately I will see neighbor. You see, the neighbor has come up. Dual algorithm neighbor has come up. Let us verify. Show IP EIGRP neighbor. I can see 192.168.0.1 is a neighbor via this interface G00 of router 2. The whole time is 12 now, 11, 10. After 10, it immediately goes to 14, which means it starts from 15. When it reaches 10, the hello packet is coming every 5 seconds from the neighbor. So it will reset to 14 again. It will come down to 10 again, it will reset to 14. Now, we got neighbors. As a result, I will be able to ping the loopbacks of R1. I can ping the loopback of R1 from the loopback of R2. It proves that we have reachability from there to here and here to there. Now show IP EIGRP neighbor, you got neighbor. Show IP EIGRP interfaces, we got EIGRP running on 4 interfaces, 3 loopback and 1 physical interface. But what we don't have is authentication. Show IP protocol, right? We have auto summarization disabled. We don't have authentication. Show IP EIGRP interface G. Okay, we don't have authentication. Let's enable authentication. As we spoke earlier, we need keychain. Key space chain. No hyphen chain, key space chain. And give a name. This can be any name. I'm going to say lock. Then key ID 1. Key string. I would like to give CCIE 1, 2, 3, 4, 5. And you see, I did not give the lifetime. I did not say send, receive lifetime. I am not saying that. I'll go under interface G00. Enable this keychain. How? Interface, IP authentication for not IP authentication. IP authentication command is for OSPF. This is for EIGRP, so this is IP EIGRP. Wait. EIGRP. Okay. Let me try. IP authentication mode MD mode for this is the syntax. IP authentication mode for EIGRP 200. 200 is the autonomous system number, and you got only one option, MD5. Now authentication policy is changed, so the interface will go down, neighbor will go down because the other neighbor is not enabled. Now let us set the password. IP authentication keychain for EIGRP 200 is lock. The keychain is also now called. Let us now see whether neighbor is up. But neighbor is down actually. We already saw. Show IP EIGRP neighbor. Gone. Debug EIGRP packets. Now you will see sending hellos. Let me stop. You see, when you see receiving EIGRP packets on Ethernet, the packet is ignored coming from router 1. This is router 1's address. Why it is received? Why it is ignored? Missing authentication. And on R1 we have not enabled authentication. Yeah. So let's go and enable authentication on R1. Here also it says authentication failed. Now we don't have a keychain and we have not enabled any authentication. IP authentication mode for EIGRP 200 MD5. I've just enabled the authentication mode. I have not attached the keychain because we don't have keychain in this router. Now let's see whether any difference in the debug. Same output only. Even now it is saying missing authentication only. Means authentication password is missing. Let's debug, let's sniff the packet and see. Here you see I'm showing the packet coming from router 1, 192.168.0.1. If you go down, this is a software version of EIGRP 12.4. There is nowhere mention about authentication here. But on the second PC from where the EIGRP packet is coming, you will see, look at this authentication field. Authentication is MD5. And this is the message digest, the hash value for the password CCIE12345. You don't see this one on router 1. We don't see that authentication field anywhere. So even though we have enabled the authentication mode, we don't have a keychain, so it is not really up. That's why the debug was showing authentication missing, missing authentication. So let's put the keychain. You can give any name. That side I give log, this side I'm going to say key ID is 1, key string is Cisco 1 2 3 4 5. Now I need to apply this to the interface G00 IP authentication for EIGRP IP authentication keychain for EIGRP 200.
So the key string should be matching, right? I think on the other side you gave CCIE.
Oh, really? Okay, let's see what. Thank you. I unknowingly did this mistake, but you found it. Let's see how the debug shows. Earlier, when we did not have the keychain, it was showing mismatch authentication. Now we have a keychain, but it's a wrong key. Let's see how the output shows. IP authentication for EIGRP keychain name is key. Right. Even now the neighbor will not come up. So let us debug now. Debug debug EIGRP packets. See, now it is saying invalid authentication. You see, now it says invalid authentication. Earlier it was saying missing authentication. Missing authentication means no keychain configured. Sometime you might have configured, you have not applied it to the interface. But now it is invalid. So it's invalid authentication. Let's go and change the right password. I'll go back to the keychain. And I'll go inside the key ID, and inside I'll go to the key string and say CCIE 345. Now we are expecting neighbor to come up. Yeah, neighbor has come up. Now the neighbor is established. Show IP EIGRP neighbor, and I'm able to ping with the source loopback 2. Now what I'm going to do is I'm going to change the password. As the ping is going on, we're going to change the password. You will see immediately the ping will stop. Keychain key ID, key string. I'm going to add 6. The password changed. Finish. You see? Authentication failed. Let's put the right password. Now the ping starts. See how effective the authentication is. Not only once in the beginning, every 5 seconds the hello packet. They send the authentication. They get authenticated every 5 seconds. I know you are thinking like, oh, it's a process consuming one. I agree with that. Process consuming only. But it's a necessary thing. Safety is first, right? Putting a lock in a beautiful wooden door looks ugly only. But we learn to live with it. Because we know safety is more important for a house than a lock hanging there. So we put a lock, we hang it on the beautiful teak wood door. That iron is hanging there. Or integrated lock on the door, you know. It doesn't look good, but we accept it. Because safety is likewise. This process is not that bad. But every 5 seconds there is some process consumption because it's a hash value. MD5 hash need to be verified every 5 seconds. Alright, so EIGRP in enterprises. I think unequal cost load balancing is over, but I have something to appreciate Sandeep on one lab he has sent me, but I also want to give some explanation to it before I get into this one. You see, there is a command called offset which we widely use for RIP. Every protocol have got that, but only on RIP we use it more repeatedly, sometime in OSPF. Why not in EIGRP? Because it is composite. It's a composite value. So you need to go and subtract the value like what our Sandeep has done. You see, initially what Sandeep has got is via gig Ethernet there is a route to reach this network from router 1. He has taken 20 network as an example. 20 network is via router 2 from router 1. 20 network is here. It's via router 2, not via router 3. You know, even the number of links are too much. Later what he has done, he has gone to the topology table and found that there is a feasible successor. Meaning you can also go via router 3, but the metric is little higher. The advertised distance is also higher. Why higher? Because there are more links. 1, 2, and then only. There are 2 gig links and 2 routers in the middle. So 10.10.10.2 is a subnet. Hold on. Okay, it is going via 192.168.1.2, which is this one. Even though the links are two links, and here it is only one link, I mistakenly misunderstood. Now let me. Here it is 1000 meg, more 10 times more bandwidth. Of course, delay will also be 10 times lower. Here only 100 meg. So even if I have another 2 extra link, now I have 2 links, another 2 extra link if I have also, this will be the best path to reach 20. So that's what it shows, 192.168.1.1. It goes via router 3, 1.2, goes via router 3, not via router 2. But in the topology table, it shows feasible successor via router 2, 10.2. It satisfies the feasibility condition because the advertised distance is less than the successor value. So there is 2 route but only 1 successor, which is via router 3. Now he is taking the feasible distance of this one, the feasible successor, and subtracting with the feasible distance of the successor. He finds the difference. Now this one he wants to add it as an offset list. So this value he is using in the offset list. On router 1, for network 2020 means that's the network we are using for testing, this network. He said offset list access list 10 as the update comes in. As the update comes in. Via G1/0. Via G1/0. He is adding this value to it so that both will be equal. See the topology table. Here is the topology table. See, he has made both FD equal. No screenshot of topology table, it would have shown both same. He made both metric equal by making this equal. It became an equal cost path now, for which you don't need variance. See, using offset list, you are giving a input which is not true to make it true, whereas variance is not like that. You still live with the truth. You are telling routing table that going via router 3 is having better metric than going via router 2, so that EIGRP can do justification while load sharing. It will send more load via this way and less load via this way. Unequal cost load balancing by using variance is preferred than making an unequal to be equal. Now what happened is, in our scenario here, he has the idea is beautiful, excellent, I appreciate using an offset list to make it as equal path. This can come down to this, but you cannot bring this one down to up to this one. This is 1000 gig, you cannot do anything, but this 1000 gig you may come down to 100 gig. So what happened is, according to EIGRP here, both the paths are equal. Both the paths are equal, which means it will try to send equal amount of packet on both sides. If it is TCP based, what will happen is it will be sending more, it will keep on keep on sending here. And if the same level is sent here, because the F is only 100 meg, there will be a problem. And on this direction there will be some mismatch in the amount of packets sent and received. Here it is okay. Here it is gig Ethernet. It's okay. So truly there will not be load balancing. What I'm coming to say is TCP, TCP, this is how it will work. It will be like a person who is driving the car for the first time. He will try to go 10 kilometer speed. Wow, we are able to go. 20 kilometer speed. Wow, no accidents. We are able to go. 30 kilometer speed. He will go. For 5 minutes. He's comfortable. So he will raise more. 40 kilometer speed. This is how TCP works. Here it can go to 1000 meg level. But it cannot go that level here. Only 100 meg level. So here there will be a drop when it goes beyond that 100 meg threshold, whereas here there won't be a drop. Here it keeps zooming, whereas here it zooms for some time, again slows down. Again zooms for some time, again slows down. Even though EIGRP is ready to share the load equally, TCP will not allow, because it cannot allow. There's a limitation in the bandwidth. Original bandwidth is not same on both sides. Right? So this is not unequal cost path. This is making unequal cost as an equal cost path. This will not come under unequal cost load balancing. But this is unequal cost load balancing. Unequal cost load balancing is much better than making an unequal as equal with offset, because offset is giving wrong information to make it equal. The technique that is used here, using the offset list and access list, I appreciate. Right, this is okay for just having fun with EIGRP. Showing that we can also use an offset list in EIGRP, but in the practical world should not use this. Right? Fine. Anyone has got any question on this? You may ask now. Right. I appreciate once again for the effort that you have put. We can have this as an option in the lab environment, just for showing the offset list in EIGRP, but let us not use this in the production, because it is providing a wrong info to the controllers.
Yeah. So I understood the implications of not doing this to using an offset and variance, but I just wanted to try and
good. That way I appreciate
how the route performs.
In RIP you can do very well the offset list. The reason is, in RIP there is a limitation in hop count, and hop count is the metric. So by just setting some hop count value, you can extend the RIP support more than 15 hops if needed. For example, I'm running RIP everywhere. I just got the 16th hop. Because of that, I don't want to change to different protocol. In that scenario, I can use that offset list. There we are not really compromising with bandwidth or delay. We are just giving the hop count only as the offset value. That is okay. But here it is bandwidth and delay. And that's why in EIGRP using offset list is not seen. Alright. Now let us move on to a new chapter, means next chapter. EIGRP in an enterprises, it's okay. But enterprises doing WAN connection within an enterprises is okay. But in an enterprise, sometimes you may need a WAN connection, a routing protocol, like DMVPN scenario. In that scenario, when you use EIGRP, make sure whenever there is a change, the impact will not be too bad. Whenever there is a topology change, make sure the number of routers that will be involved in the topology change will be as less as possible. Make sure the impact will not be throughout the topology. If impact is there, it should be on that router or maximum next router, not to any more routers. Only then the network quality might be network quality can be improved. So if too many routers, one small change, if every router need to process the change and do some rerouting, not good. Or if there is a query, if every router needs to query all the other routers and then only depending on the reply, if a solution is met, then it is problem. Both the engines failed. First officer calling the pilot, the captain. Captain, both the engines failed. Captain says, wait, let me call all the crew members and ask what to do. Call the crew member head. Crew member calls all the crew members. Crew members call the passengers. Hey, both the engines failed. Ha ha ha, what shall we do? Shall we land the flight or we'll keep flying? That is not the way the pilot can respond. Has to respond immediately. Not too many routers should be involved when there is a topology change. Immediate. That will solve the problem. Not too many people to take approval to solve the problem. Depth of the topology. Query should be, Captain, shall we land the flight? Okay. Call the ground. Check whether we can land in this particular airport, which is just 100 kilometers away. Fine. Approval is done. Land it safe. Boom. Everyone is happy. Instead of that, querying everyone and then waiting for everyone's response. Not good. So whenever EIGRP don't have feasible successor, it will always send query to neighbors. Whenever there is no feasible successor, when the successor route goes down, there is no feasible successor. So it will send a query to all the neighbor except the neighbor on the successor interface. And all those neighbors who received the query may not be in a position to answer. Only if they know they can answer the query. If they don't know what answer they will give, they cannot give. So the one who query it should not wait for everyone to respond. But by default, EIGRP will query all the neighbors. One neighbor gave response, the other neighbor did not give, but this router, it will be waiting for all to respond. These guys are not going to respond at all because they have no answer to give. If they know only they can answer, they don't know. They will not answer. But even though it is receiving an answer, this clever boy is not accepting it as an answer. He is waiting for other two also to provide some answers so that it can compare and choose the best, which is not going to happen. So what will happen in this time, we undergo something called stuck in active state. In an active state, it is stuck, meaning it is still actively looking for a better path. For a long time it is stuck. How long it is stuck? It will be stuck for 3 minutes. After 3 minutes, what this router will do, because these two neighbors did not respond, it will discard the neighbor. It will remove the neighbor. Actually, the hellos were going, every other things were going, but only the query didn't respond. For that, it will remove that neighbor itself. It will reset the neighbor completely, which will impact all other routers down here. Not good. Not only that, when a query is sent, if this router don't know the query, it will be sending to the downstream routers. Now they all will be stuck inactive for 3 minutes. We need to somehow solve this problem. This is what stuck inactive. Everyone sends to, see what happened, This one sent a query here. This is sending to its neighbor. And this is sending to who? This one. Because for CB is a neighbor. Query back. Query back. Again, query came from E will be sent to A, D and C. Likewise, query came from D will be sent to A and C. So this is going to be a big chaos. One small query, see how much impact it makes. All the routers are now repeatedly processing the same query from different neighbor, and all are in stuck inactive state. The problem can be solved by configuring stub. See, it's a remote site, which means there is an internet. It's a WAN connection. Hub and spoke design. This is like a hub. You may be running DMVPN on the WAN. Through the VPN tunnel, you are forming neighbor with a remote router. So don't think they are connected directly like this, what you just explained in the picture. No. Don't think there is a wire going. You have an internet here. There is a DMVPN. This is a tunnel actually. Through tunnel you are forming neighbor. In real world, that is how it goes. So what happens now? Big chaos has happened. How to solve the problem? Problem can be solved by giving some additional information to B. B should know that I cannot query about B should know that I should not query about idli vada to American and Australian, because they will not know what is idli vada. They will not respond. You should ask only Indian. He knows what is idli and vada. B should know I should not ask about kangaroo to Indian and American, because it is available only in Australia. If B don't know these things about who can provide idli vada and who can provide kangaroo, then he has to query everyone. Configuring stub is telling the hub router, spokes telling the hub router. Where do you configure stub? You configure stub on the spokes device. When you configure stub on the spokes device, spokes will go to the hub device and say, hey, I have only these infos. Don't ask me anything other than these networks, these information. I am limited to only these networks. See, normally EIGRP will advertise the networks, but it will not say, don't query me other than this. Configuring stub is telling an additional info to the receiver. Who is the receiver here? Hub router, router B. Telling router B that, router B, I am giving you this network. Be happy with that. Anything related to these networks, you may ask me anytime. But other than this, I'm not responsible. Don't query me and waste your time. Don't query me and get into stuck in active scenario. That is what stub is, you see. Stub sends a special peer information packet to all the neighbor routers to report its status as a stub router. I am a stub router. Whatever I am giving you is what I know. I am a stub router. I don't have any other source to know about something which I don't know. I am a stub router. What is stub router? I have only one way. I have no other way. That is stub router. Only one gateway or only one way. That's the meaning of stub. I just got only one route information, it's a collection of route information, just this route information, nothing more. So if you query me something which I have not shared you, I cannot help you. Don't think I can query my neighbors. My neighbors I cannot query because I'm a stub router. Maybe I don't have a neighbor. So why you unnecessarily send me and wait for the response? I cannot respond. So configuring stub is sending a special peer information to all the neighbors, reporting its status as a stub router. The neighbors that receives this special info of the stub status does not query the stub routers for any routes. So if a router says I'm a stub receive only, nothing, it is ready to serve. That's the meaning. I'm a stub receive only. I will only get, I won't give. That's the meaning. So querying is waste. If you have a neighbor who only always gets from you, who never gives you anything, for any emergency, will you go and query him? No way. You know his character. He is only a receiver, not a giver. He is totally stub. Receive only. And there is another person who is very good, sweet, all the stuff are good, but you know his condition. He himself needs a help. He told, see, this month I lost a job, I'm looking for a new job. It's very tight for me. Will you go and ask him for help now? No. Because he has already said, this is my condition this month. He will not query and wait for his response. Configuring EIGRP stub is sending the special status information so that when there is no feasible successor, the router will know whom to query and whom not to query. Right? Fine. So this